We are live now. So, hey folks, this is me, Vishwas Nayan. I'm the host of this meetup, and thanks for coming up for this meetup. And the most essence of just driving these kind of meetups on security is to actually make sure not just an ecosystem of developers who are coming up in the market understand security, but also impactfully say that, you know what, security starts from the time you start shipping the code. And that is what we wanted to say. And over a course of time, there's obviously a lot of things that goes down even in your security practices. Even if you can think about your ZTNA, zero trust network access, what you call that practices that you are bringing in your organization, anything can go wrong. So this is a session that focuses on how you should start working towards getting that understanding right now. And I'll just start by presenting my screen so that you all will understand, okay, why is this security required, what is this, and things like that. So let me just go ahead and let me just go for mobsf.secure. So this is the one which is there in my this one. But right now I just uploaded an Flutter application which was just rigged up by me some years down the line. Like, I just was a Flutter developer back then, I just wanted to do that. So it's very simple. My repository is available like this. You guys can go check it out. Just learn, that is what it is. So I have built a code, packaged it, form factored it as an APK file right now, and now I'm testing it out here. And this is a static application testing tool, which is called as mobsf.live. If you just go and click on this is actually a version which is already deployed, because there is a company which is working behind, everything is there. So what you have to just do is, if you have an APK file, just go click on upload and analyze, and I will have to search APK, and this is the APK file that I rigged up. So I have to give it a permission that, you know what, it's okay to go to that website. Don't worry about it. So it's all security practices that I'm talking here. Even getting that OK button here was also supposed to be in the security practice that we are coming up. And right now it's analyzing. Right now it's analyzing the entire code that you wrote as a Flutter application, which was written on Dart, packaged as an APK file, and it says everything about it. And of course, Sangram and me, we were just joking, like, everybody wants reports, everybody wants PDFs, and that's where you guys can just go out, click on this, or else you can still go ahead and print a report, and you get to see everything about this entire thing that you rigged up. So it's an 42 out of 100 medium risk. That is way beyond the standards of whatever you think enterprise. So think about it in a different way. So you are never the same old student that you are. You're still going back and rigging up architecture at any given point of time. And even if you go back, how many high, medium, how many information I'm giving out about my organization or anything as in credential is being told here. And I think this is one of the permissions and the status that we are talking right now. And these are some things are very minute in any organization as in practice, but it makes a lot of impact. So I spoke about this application, right? Why I spoke about Flutter is because you can take the same set of code, deploy it on a web app, deploy it on a Windows application, deploy it on a Mac OS you can just push it to the App Store, you can just push it to the Play Store. It still works the same way. Like, of course, there will be some performance differences, but it's still going to be a set of code which is making a lot of impact. Now, I talked a lot about this, that, and all these things, right? So let me just give you why we are supposed to think security practices. I think Sangam is going to give you a lot of insights about how you need to think about an architecture which you have rigged up. I think Richa is going to give about how and NoSQL DB is using an API, this, that, and it's actually interacting with a database which is there on a cloud. And all these things has to be securitized. And I think she's not going to cover about security, but she's going to give you that insight about how a database is getting connected right now. And if you just go and type in www.google.com, you still get the same thing, right? But since you all are students, don't get bored. Some are professionals here. So, so there are tools like Charles. Like this is a tool that I always use. There's a tool named Charles, which I use for API hacking. That means like I just click on it, it just gives me all the API transactions which is happening, and I don't have to go through the hassle of setting an MITM proxy, man in the middle proxy. That means there's a computer and there's one more computer for the, this is just for an example purpose. So now there is a communication happening between these two, and MITM proxy, what it does is it goes in between these two computer, listens to it, and sends the same data back to my MacBook, back in such a way that nobody is listening. And that is what MITM proxies are. And let me just go back and show you why these things are important. So I just go and type in my terminal. Okay, I'm already open my terminal, but I'll just go back here. Terminal. Okay, I just did some Docker scan. I'll show you how Docker ecosystem is improvising on the security as well. So anything and everything that you're seeing in the google.com is somewhere down the line is defined as a container. So how many of you know what is a container? Like just honestly raise your hands. How many of you know what is containers? I know you know that because you're working on it. So how many of you don't know what is container? Proudly raise your hands. Don't worry about it. So very simple. Docker run -d -e -p. These are some commands which you use for running some applications here and there and things like that. So very simple. Docker puts your entire code base, and let's say I click on something like index.html. That thing goes and appears on my MacBook and says, hey, you know what, it's working. But probably on Linux it might not work. So what Docker does is it packages everything and it puts it into one form factor called as container. So what I'm doing now is I'll just take the same image which I scanned. I'll just show you why it's more important to learn from basics. So what I do is I just make sure that is okay, it's fine. But localhost pp, if I just do this, it still starts running. That means the same old container image which is working on my system will also work on an other computer. And other computer ka matlab, there's another cloud concept which is also there. So if you just go and deploy it, it's just going to work there. So that is how the containers are. But right now, whatever you are doing is just mythically underneath the complexity. You're not just doing anything, like you are just pushing the container, everything. So what happens behind is you are assigned with a machine at any cost. So I type google.com, I say this is a machine, right? You know, this is a machine, this and that, and a lot of things are happening. So I just take this IP, I copy it, and I paste it here. It directs me to google.com. So this is where a computer as an information is going out to the world. It's still IPs, but you're masking through a layer of DNS, domain name service. That's it, simple as that. So all these practices that we are talking here is just going to give you that example of how you should actually securitize your system rather than how you should just not throw your code out there for the world. So even I talked all these things, right? Even Cosmos DB has a very active integration with any of the containers that you talk about. So it's very easy to migrate. Like let's say your developers thinks that Go language is far more better than Python, and let's just go for Go language rather than Python. It's just a change of an API. Your database will still start communicating, but your business logic will be in a different language rather than Python. So that's the whole point. So now let's do scan. I'll show you in the terms of terminal, in terms of and Docker desktop portal as well. So before everything, you still have to do a Docker scan login. I do this, it opens to me to a portal which is used for authenticating the Snike infrastructure. So the moment you authenticate the Snike infrastructure, it says your account has been authenticated right now. That is what Docker login did. So now if I just do scan, the same image which is running, I just do scan, it's analyzing the container, it's doing this, that, what not, and it's still giving me, okay, what, licenses are enabled. That means it's absolutely working perfect from the Snike side and everything is fine. It's a Debian based OS. Yes, it's a Debian based OS. And it has so many vulnerabilities which your developer needs to work on. So that is how the security ecosystem is coming into the picture. Let's say there is some secret let out from me. Cosmos DB connects to some API tokens, this, that, a lot of things, right? I think, is there JWT authentication, something like that?
No, we have Azure AAD authentication.
Oh, okay. Azure
Active
Active Directory authentication. I think this is released in this build only.
No, it was.
It was before?
Yeah.
Because I don't know. This build has so many things from Azure, so a lot of things are happening. So if there was a secret exposed from my side, it would have told, भैया आपने एक secret expose कर लिया, इतना बड़ा secret, तो क्यों आप developer बन गए? So that will also be a question from this tool that I'm talking about. So right now, anything is fine. So Docker as an ecosystem is improvising every single day. Like if you see what is given in Docker, like anything as an image, it's given to me. It's saying in use or what is happening with this, bhaiya, kuch bhi status. It's working on my localhost 80. Yes, it's working on my localhost 80. That means you know the concept of ports, right? A port is 65535 port in your machine. You're only giving access through 443. That's your TCP. 80 is your HTTPS. HTTP or HTTPS, I don't know about it. Yeah, I was right. That's awesome. So that is how your Docker infrastructure is today. And now if you go back to the Snike version of it, so it's very easy. You just have to go select an image, test an image, and you still have it. Right? It's giving you everything about an image that was there. So everything about DPKJ, data package, everything is given. But if you really feel that, what, I can't afford all these infrastructure right now, so there is something called as Devtron, which I'm part of. I work for that organization. So it's a CI/CD tool right now, and it can evolve to MLOps as well. It can evolve to anything. So just log in with your Google ID or a GitHub ID. You just have to log into preview.devtron.ai. You get an exposure of what an open source tool is happening in a bigger scale system like delivery, Bharate, Moglix, this and that. So let me just show you the security aspect of it rather than just going out and just figuring out what is the CI/CD thing all about, because that is an old topic altogether. So just click on the security out there, and you can see that one demo application that we did has one lower critical vulnerability, and you can go to the Mitre report and you can study about it. So this is actually required because your developers need to understand what is happening in your system. Your developers need to understand what is not going down, because we are not doing everything right. Are we doing everything right? You should question yourself. I think these are the practices that are required in order to get yourself into that motivation of, what, we are going to do everything, which is far more easier and faster to anybody to adopt security. I think that's the icebreaker talk. There's a lot beyond security. There's a lot beyond everything that we can talk about. So I'll open my stage to Richa right now. Richa is going to come and talk about Cosmos DB. And any questions, queries, don't worry. I'll still be till the end of the session. So you guys can go there and check out. I think probably I have to leave by 2 or something because I have a talk at 3 on AWS. Sorry for that. So I think Richa, stage is yours. Richa will be back in some minutes, so don't worry. Yes, this is yours. Have you shared your screen? Right. Yeah.
Um, just a sec.
Perfect.
It's sharing.
Yeah.
Hi everyone. I am Richa Gar. I'm a product manager at Azure Cosmos DB in Microsoft. And today I'm here to talk about Azure Cosmos DB, of course. And he's my colleague Abhinav Tripathi. So before I start, I would just like to know how many of you are students? So quite a lot of them.
Yeah, there are quite a lot of students here.
And how many are professionals? Do we have...
I'm two professionals. I don't know, I'm a community good developer.
Yeah. Do we have any online audience?
Yeah, we have online on LinkedIn as well.
Okay.
So don't worry about that. You just continue. You just do the full screen. So
Oh,
that,
sorry.
yeah.
So before starting, since you all are students, I would like to understand how many of you have used database in any form. Yeah, go ahead. BigQuery. Any other? Fiverr. Firebase. Okay. Any other databases which you might have used? InfluxDB. Oh, nice. And any other? Oracle. MariaDB. Okay. Why is it it's not pausing? I want the...
Yeah. You want the? Wait, it's now starting. Perfect. Let's go to this. That's it. Ah, it's coming. Perfect. I think it's
Okay, this one.
Alright, yeah, it's working now. It's going forward. That's it.
Yeah, that's...
Just start from the beginning. That's it. Yeah.
Where did the first...
This is the first slide.
No. There was first one.
This is the one.
No. Just a sec. Did something happen?
Yeah, I think you can start now. Yeah, go ahead.
Yeah. What about people who are working? Which databases you have used?
Use Postgres, MySQL, and of course Azure SQL and SQL Server as well.
Okay. Redis. Nice. Any other? Graph database. Okay, nice. So I think, yeah, we have a mix of databases people have used here. So Azure Cosmos DB is nothing but a fully managed database service that is being offered by Microsoft. So it's primarily a NoSQL database, but we also have Postgres as an offering in Azure Cosmos DB as well. So yeah, let me start then. To give an overview, I'm going to talk about the key features of Azure Cosmos DB. And if we have the time, we can deep dive on few concepts which are essential to get the performance and cost benefits in Cosmos DB. So this is Cosmos DB in a nutshell. It's a globally distributed, elastically scalable multi-model database service. So I'm going to talk about each of these terms. What does this mean in terms of, in context of database? So when I say multi-model, what that means is we support different document models. So we have, if you are familiar with the NoSQL data formats, we have key value pairs, we have column family databases, we have document databases, we have graph, Neo4j is one example, and we also have relational databases. So all of these different models are supported on Cosmos DB through different open source APIs. So I hope everyone has heard of MongoDB, right? So yeah, in Cosmos DB, you can use MongoDB querying anything that is there out in MongoDB. You can use exactly same things on Cosmos DB. So how do we support that? We implement the wire protocol that MongoDB supports, and on backend we have Cosmos DB engine, but we support Mongo API, like whatever the querying language that Mongo supports, we support it out of the box. So you can bring your on-premise workloads, which are generally open source databases. You can bring them directly to Azure Cosmos DB, and you don't have to do anything. You can use your existing clients, existing drivers, and you just get an out-of-the-box solution, and you don't need to think about database management at all from then on. So we support MongoDB API, which basically is a document model format. Similarly, our NoSQL core offering, which is NoSQL, is also a document model. It's a JSON document, so you can store any kind of data in a JSON document in Cosmos DB, and you will be able to query on any of the field very easily. Similarly, we support Cassandra, which is a column family database, wide column database, not column family. We also support Cassandra API. So your Cassandra workloads can directly be operated on Azure Cosmos DB. And for Graph, we have Gremlin API. Similarly, Table APIs are key value pair offerings. And we also have a new offering, which is not mentioned here, is Postgres. So you can have distributed SQL on distributed relational workloads on Azure Cosmos DB, which are entirely managed. So this is what we mean by multi-model. And this is one of like totally unique offering, which is not there out there anywhere. So you cannot get multiple data models in a single database anywhere else. So this is what is unique for Cosmos DB. When I say it globally distributed, what I mean is we support turnkey global distribution. That means that you can have your data here in South India data center, and your data will be automatically replicated to your US clients. So the reason for why do we want global distribution is we want for two reasons. First is high availability. We want our data to be available in all the cases. We don't want any downtime in our applications. You hear all these downtime news, they become a news instantly. So whenever a database goes down, it creates havoc, and your business lose revenue. So for that purpose, we support global distribution, so your database is highly available all the time. And second reason why people want global distribution is to have low latency, because your data cannot travel faster than speed of light. So if you want to, let's say, if you want to serve here in India, if you want to serve a US client, it will take 100 milliseconds at least to travel the data from network only. So you cannot offer sub-millisecond latency in those cases. To offer low latency, we generally what companies do, what developers do is they replicate their data globally. So that is supported in Cosmos DB out of the box. You don't have to worry about it. You don't have to think about it at all. All you need to do is just do a one-click configuration, and it will be replicated automatically in how many number of regions you want. Coming to elastic scale out and scale in. So database has two properties. One is storage, another is throughput. So we support both elastic scale in and scale out in Cosmos DB, and it is again a one-click operation. All you need to do is just configure request units. Request units I'm going to talk about later. You just need to increase or decrease your request units in the configuration, and that will be supported out of the box in Cosmos DB. We are the only ones who support guaranteed low latency at 99 percentile, and we have service level agreements for that. We support sub millisecond latency for point reads, and that is not supported anywhere else. So we have latency SLAs, we have throughput SLAs, and we have 5 nines of availability SLAs. Of course, there is, whenever we talk about databases, we talk about consistency and availability. So how many of you have heard about CAP theorem? Okay. So not a lot of people. So CAP theorem says that databases can only support either consistency or availability in case of a network partition. So whenever there is a network partition, either your data can be consistent or it can be available. So since every application has different needs, some would want consistency. Like let's say for banking solutions, I do not want I can handle not getting my balance, but I cannot handle getting a negative balance or a wrong balance. So in that case, consistency is important. But let's say you are using Instagram. All of you must be using Instagram, right? So you would want to see how many likes are there on your post, right? The number can, let's say 50 people have liked right now, and in the next 10 minutes, 100 people liked. So you would be okay with getting 50 number right now because it will get updated after some time. But you would not want that your post is not showing, your likes are not showing. So that is where availability is more important. So this is a spectrum where we have different balances of consistency and availability. So either databases support consistency or availability. But in Cosmos DB, what we do is we support 5 level of well-defined consistency models. I'll talk about them in detail. So you can choose any of the consistency and availability combination based on your application needs. So yeah, this is mostly what Cosmos DB is in a nutshell. I'll basically try to give you an overview of each of these. So when we talk about multi-model, you have to choose one API. So for the core SQL is core NoSQL is our core offering. So you can do any of the NoSQL operation. We support SQL query model on NoSQL data. So you have JSON documents, and you can use any SQL commands on top of that. So this is our core NoSQL offering. We support MongoDB API. We support Cassandra, Table, and Graph. So you can choose any of them, and that's how you start building your database.
Can you repeat that word which you are using just before this slide?
CAP theorem.
CAP theorem.
So is this particular theorem, is it right out of, I think, one of the asset properties, which is like one of the asset property of database is atomicity.
Right.
So I think it's derived out of that.
Can you come and speak?
No, I think that's fine.
No, we want it to be heard, so that's why.
Okay.
For stream. I am editing it later,
Yeah.
so it would be great if you can come and speak here. अरे
Okay, yeah, sure.
आप ही स्पीकर हो सर, आओ, कोई बात नहीं। नहीं अभी वहाँ जाओ।
हाँ but
इधर जाओ सर, बोल दो।
So that theorem which you are saying, it's recently derived out of the word atomicity, or how in the product when we say in the Cosmos is a recent term which is developed out of the atomicity. Because in the relation database we kept hearing about this asset properties.
Right.
Because I understand Cosmos is, I think, non-relational document DB. So so that the properties which Cosmos follows is I think it's won't be related to the asset, right?
Yeah.
It might
So
have its own
Theorem
properties.
basically
And
comes
CAP
into picture in distributed systems.
Okay.
So,
Distributed systems.
Yeah.
Okay.
So relational, like traditionally, it has been not related to the distributed system. So when distributed systems came to fore, so CAP theorem became like these things.
So cap theorem is the standard. It has been there since
very long time.
very long time. It's a standard. It's a standard theorem. So it was proposed by a scientist.
Okay.
So it is applicable for all distributed systems.
Like Cosmos.
Yes,
So we are
any
a
distributed
locally
system.
distributed system. It could be your distributed operating system, any distributed system.
So any distributed system has this problem of network partition because any network is very fragile. It can go down at any time. So to support consistency and availability at both at the same time is not possible. That has been proven by cap theorem. So you have to choose either consistency or availability. That's the question. So relational system by nature are consistent systems.
Yeah,
that's why
consistent.
that's why we say that's why we talk of acid properties.
Yes.
So yes, a Cosmos DB is also a consistent system.
Okay.
You have to choose strong consistency in that case. So all of your acid properties would be automatically satisfied.
Okay. Yeah.
Got it?
Got it. Yeah. Thank you. Thank you.
Any other question? Thank you. Moving on. We have to, whenever we configure a database, we have to specify our workload needs. So we talked about two parameters that are in which our database is configured. One is storage, another is throughput. So storage is dependent on your data, and throughput is also dependent on your like workload. What is your query rate? What is your RPS, and a lot of things. So in order to provision a throughput on Cosmos DB, we have multiple options available. If your workload is very predictable, let's say you have a banking system, it's generally predictable. So you can configure manual throughput on Cosmos DB. I will deep dive into what exactly is throughput and how do we configure it in Cosmos DB, but I'm talking about the modes in which it can happen. So it would basically suit your application's need. Different workloads have different needs. So Cosmos DB provides different throughput provisioning modes for that. So for predictable workloads, we have manual throughput provisioning where you can specify how many request units you want per second. For sporadic workload, we have serverless, which means that if your application is like has very sporadic workload, for example, let's consider an education application like a school application. So it has sporadic workload in the sense that it is active between in the morning hours only, like 10 to 3 or some time, and after that it's completely dead, right? So those kind of workloads where you have sporadic usage, you can use serverless. It is a pay as you go consumption model. Like how many what that means is you only pay for your request unit consumption.
Like you must have used in Firebase. Who used Firebase over there? Yeah. So I think that's the serverless offering, right?
And for bursty and unpredictable traffic, we have auto scale provisioning model where your workload can scale between 10 to 100% of what you have configured. So let's say you have configured 1,000 request units per second. You can scale up between 100 to 1,000 in an instant. So those are like different provisioning model. To give you more perspective, let's look at the screen. So here, what you do when creating a Cosmos DB, you have to choose either provision throughput or serverless. So if I choose provision throughput, I have to choose either auto scale or manual. And this is the database max RU per second request units, which I am talking about. So in auto scale, you can configure whatever value you need. For that, calculating what value you need, we have a separate TCO calculator where you can put in your workload requirements. Let's say I have 100 requests per second, 100 writes per second, and 1,000 reads per second. So based on my application's requirement, I can get to the number which would be suitable for handling my workload, and based on that I can enter request units here and create the container. So parallel threads is like the backend working, like how many threads are being used, how many servers are there. That is all of this is agnostic to the user, because when we when
From a cloud perspective, it's agnostic to the user, but in terms, if I want to know, okay, on the scale or something, I should know.
yeah, I will come to that in a second. So how that does that looks under the hood, I'll come to that. So I talked about global distribution earlier. So all you have to do is just do a few clicks. You see this world map. You select the regions in which you want global replication, and you enable multiple region rights. You enable read and write region here, and with just 2 clicks, your global replication is set up. And the replication happens according to the consistency and availability requirements that you have chosen for your application. Coming to consistency levels that I earlier talked about, we support 5 well-defined consistency model ranging from strong to eventual. Strong is the what relational DBs support, asset properties, and eventual says that your data would in different regions or different sources would be eventually consistent, and you can see out of order writes in different regions. So it ranges from strong to eventual, and you can choose any of these based on your application's needs. Uh, just to give you a little more context, strong is like you always see consistent reads, and bounded staleness means that your regions would be stale within bounded context. So you would be always be stale by maximum k prefixes. So let's say I have made 10 writes, and my bounded staleness supports k prefixes. So let's say for this conversation, let's say k equals to 3. So you will see only maximum, you will be only lagged by maximum 3 documents, 3 writes. So that's what it means. Or another bounded context is time. So whatever happens first, either the 3 writes which happen first, or let's say 1 second is my bounded time. So either 1 second happens first, or either 3 writes happen first, whichever happens first. Based on that, my regions will be consistent. Session consistency is our default offering in SDKs. So session consistency says that within my session, the session I am holding right now, I will be able to see my own writes in order, and writes will always follow reads. Sorry, reads will always follow writes. So within the session, you will always see ordered reads. Consistent prefix again says that you will not see out of order writes. You can have any like the lag could be greater, but you will never see out of order writes. Eventual, as we all know, is again, it's not consistent. It's eventually consistent, and you can see out of order writes. So it may be possible that you can. If I take the example of banking system, you can see a negative balance first and positive balance later. So we support all of these consistency models, and based on your needs, you can choose any of them. Now, when we talk about modern applications, we talk about real-time analytics. I think all of you might have heard of real-time analytics.
Streaming data basically.
Yes, streaming. So streaming is a way to enable real-time analytics. So streaming is basically, yeah, it's the technology behind enabling real-time analytics. So what Cosmos DB supports is out of the box real-time analytics. If I talk about analytics system, what companies usually do is they have an OLTP store where their users are interacting, and they have an OLAP store. OLAP is
Analytical protocol.
yeah.
One is transactional, OLTP is transactional, and OLAP is analytical.
So one is transactional store, another is analytical store. So the difference between these two stores is in the way they store the data. The data format is different. One is supported for transactional capabilities, another is supported for analytical capabilities. So in order to achieve these kind of system, companies have different data sources and they have set up ETL pipelines. ETL is extract, transform, load. So you set up, you have massive infrastructure. You have like multiple disparate data sources. You have your transformation pipelines set up in uh, uh, set up in different places using different technologies. All the way, you use Hadoop, you use Spark, all of these things, right? So, and it becomes being from a big data background, I can very much relate how much cumbersome it is to relate to manage a ETL pipeline for a large scale workload. So what Cosmos DB enables is you don't need to do anything. You can transform your data from OLTP to OLAP with just one click. All you have to do is to enable Synapse link on your containers. Containers, I think you can all relate as tables or collections in MongoDB. So we have the logical entity in Cosmos DB for a collection is container. So all you have to do is enable Synapse link on the container, and your data would be replicated to an OLAP store on real-time basis. So you don't have to create a ETL pipeline or manage different databases. You don't have to worry about that at all. All you have to do is just one click. And on top of Synapse, we have Spark connectors. So you can do any of the streaming capabilities which we were earlier talking about using Spark out of the box.
So it has to be the same availability zone.
Availability zone, it depends. Like if you have configured multiple zone, it would be available in multiple zones.
So does it use the service bus behind the scenes?
Not service bus. We use what we call as change feed, which I will talk about later. Change feed is a change data capture mechanism. So whatever changes are happening in your collections or container, those changes are in the form of logs are transmitted to OLAP store. Like change feed is used for multiple purposes. One of them is Azure Synapse. So you migrate your data from OLTP to OLAP. So that happens through change feed mechanism. So change feed is enabled by default in Cosmos DB. So when you configure, when you enable Synapse link, your data would be automatically replicated via change feed on real-time basis. Right. So you can do any type of stream processing, any type of whatever analytics or any data movement or let's say notification or anything you can do on top of this using Spark. So this is what I was talking about. Here you see yeah, these are the databases, and this is the food collection is the container that I'm talking about. So all you need to do is click on this button, enable Synapse, Azure Synapse link. And when you configure while you can do it both while creating or as well as after creating. You can enable Synapse link anytime you want. So if you want to create it while creating, you just click on Analytica store on and off. And with that, your OLAP store is ready to be consumed. Now, since this is a security event, I want to emphasize on the access control in Cosmos DB. So by default, Azure Cosmos DB support AAD authentication, Azure Active Directory authentication, which is very secure, by the way. So AD authentication is built in by default, and on top of that, you can use RBAC, which is role-based access control. So you can create roles within your database, and you can assign custom permissions like read, write, management of databases. So within management, there are multiple categories. So you can use any combination of permissions and create a role, and you can assign that role to your different user. So that's what RBAC supports. And you need for each of these roles, you can have multiple users. So you can within your organization, you can assign different roles to different people. So that basically brings in the security aspect that not everyone is able to, even developers are not able to access databases beyond a point. Yeah, like right. So for example, one use case could be only because since you are working on cloud, you have to pay for everything, right? So not everyone should be able to create a database, right? Not every developer should be able to create it. Only let's say a tech lead or a manager should be able to do that. So you can assign those kind of roles using RBAC. And there could be multiple, since in large organizations there are like different companies for managing the infrastructure and different for developing. So only certain people have the management roles, and rest of them have like only CRUD roles. So you can assign different roles based on the based on the user persona. So you can mix and match any type of permissions within the role. So that capability is there. Apart from this, uh, Cosmos DB supports data encryption at rest by default. So all your data in Azure Cosmos DB is encrypted by default. You don't have to do anything. So, but if you want something on top of that, we support customer managed keys, which is bring your own keys kind of system. So you can bring your own keys, and we will encrypt data using that keys on top of the default encryption that we provide for database for your data. Data on transit is like basically it's HTTPS, so you don't have to worry about that. It is by default encrypted, and whenever the internal data movement is happening, that is also encrypted.
Inside the van of Azure.
Yeah.
Here we are talking about customer managed keys, right?
No, he was asking about default
Okay.
encryption.
No, but we were telling about
The
that.
data in rest is so data on transit between the resources. So goes the
Okay, like one resource from Azure to the other resource.
Yeah, that
So that is-
happens through HTTPS only. So it's default.
doesn't go out to the out of the
No.
It's within the ecosystem.
So yeah, I was talking about customer managed keys. So on top of what default encryption we offer, you can bring your own keys to be more secure, so that only people having this key can decrypt your data. So that is also possible. Apart from that, we also have integration with private endpoint. What does a private endpoint do is it disables your endpoint access, Cosmos DB endpoint access by default. Uh, so that means that no one outside a VNet can access database. So even let's say you are a developer and you are developing on, you are building an application on Cosmos DB. If your client machine, if the machine on which you are developing is not in the VNet, you won't be able to access. So anyone outside the VNet in which Cosmos DB resides won't be able to access your database. So only the application that you have deployed on a container or a VM within the VNet, which is accessing your Cosmos DB, will only be able to access. So it's very, very secure. No one, even within the Azure ecosystem, even within different subnet, will not be able to access your database.
I think there is always a DNS attached to every services, right?
Yeah, so we have with private endpoint, you have a private DNS zone which gets created whenever you enable private endpoints. That basically configures different domain names for the Cosmos DB service, which is only accessible by the containers or services residing within the VNet. And even for allowing different services to access Cosmos, you have to explicitly give them the permission or whitelist their IPs once the private endpoint is enabled. So that is a very secure mechanism to secure your data basically.
Any use case you have for the time series data, like for the IoT space,
Yeah, for the IoT space, we support very large companies which are currently working on IoT sector and are on Cosmos DB, but we do not support time series data out of the box. So we don't have a time series offering natively, but we can you can bring in your IoT workloads on Cosmos DB and do any kind of queries. But if you're talking about just natively supporting time series, we don't. Okay.
Do we have other slides related to security? I think we are good. So a couple of things I wanted to add.
Yeah, sure.
One was like transport layer security. So apart from HTTPS, you can actually enforce minimum TLS versions. So you can either like do it yourself, or you can request from our side, so that we know that it is the requests are emanating from like secure applications. So that was there. And putting everything in perspective, we talked about even backups, geo replication, availability zones, and everything. So that also, in a way, comes down to security. Also, if there are attacks, one reason goes down, whatever happens, it's a rare event. But if it happens, if you have configured global distribution, then obviously your data will be more
Secure.
available, and it will be secure. Then we do offer backup, restore, and all those things. So again, that ties up into the security space again. And we do have audit logs. So you can just simply open the Azure portal, and you can see like what all activities happen. So if there is something suspicious, you'll get to know from there. So all those offerings, the main thing is that Cosmos DB makes it very easy for you to see what all is going on in your database, and it minimizes the administration tasks. So that's the main thing. Even like configuring private endpoints, security, CMK, all those things, these are just like a couple of clicks. Otherwise, you will have to like set up the whole process and everything. But all that is taken care by the Azure ecosystem. All that, it integrates with AAD and all those things. So that's the main benefit that comes with Cosmos DB. Yeah. So there was one question from you regarding the scaling the threads and all that. So to answer that, we came up with this concept of RUs to eliminate all those concepts altogether. So whenever a transaction happens, there are three main components: CPU, memory, and IOPS. So you have to think about like how much of each component is consumed. So that's why we introduced the concept of RUs. So it is guaranteed that if you have a 1 KB of point read, point by point read, I mean you specify the ID of the item and the partition key, so that it's like we know the location of the record. So if you have a 1 KB document point read, it's always guaranteed that one RU will be consumed on that. So you don't have to worry about how much CPU, memory, or IOPS was utilized. So that's why we introduced the concept of RU. So it gets some predictability into the system. So you always know if like same query on same settings took 2 RUs yesterday, it will take 2 RUs today as well. So yeah.
Because the question came since you mentioned about Mongo and Cassandra, right?
Yeah.
Mongo is CP.
Yeah. We have both.
Cassandra is AP.
Right.
How does it, you spin up two kind of instances?
Right. So we do offer both RU based system where you just need to configure request units, and also vCore based system. So you can choose any of them based on your requirements. And if you want to calculate your workload in terms of vCores, memory, IOPS, all of the, both of these options are available for MongoDB today in Cosmos DB.
RPO and RPO calculations inside the system. So does it also have such kind of thing?
Sorry, I couldn't hear you.
RPO and RPO calculations.
Yeah, we do have. I don't
Cosmos
remember.
DB.
Yeah, RTO and RPO.
Okay.
I don't remember the exact number for RTO and RPO, but I'll share the document where you can, see all these configuration. This is again dependent on the consistency requirement you choose. So based on the consistency requirement, these numbers will change. So you can get only 5 nines of availability when you are eventually consistent. It is not possible, right? So yeah, based on that, we have these RTO and RPO numbers if you configure multiple regions. Yeah, I'll share the doc. I don't remember the numbers exactly.
One time I used this. I was using SQL Server a lot. Since I was using we have a challenge in getting the insights for DRs.
Sorry, I am not able to hear you. Can you come in front?
We had a challenge in
No. You come till here and you can ask a question. This is someone that I guess it. Yeah. Wait. I think he just ask one question and he can start. You can start with the extension.
No, I mean, so we are doing the DR test and
Yeah.
we
No,
were,
you one more. Sorry, I don't know why I'm getting so much static in this. You go till there, sir. Alright, no problem.
You are
किसी को
acting
भी
like a
corona
movie
नहीं-
director.
Yeah, कोई बात नहीं.
Yeah.
So we are doing VR test. The time we test this issue, it takes some 10 minutes or something.
Okay.
So that's where we look at RTO and RPO, so what's happening. but for Cosmos DB we couldn't get it.
Oh, let me share you the document. I don't I can't commit on the numbers, but I think it is less than 5 minutes. The RPO. So
But that depends on the amount of data it's going from one DR to other location.
so that's what I mentioned by global replication. So you don't have to move the data. Data is already there. That's why the RTO and RPOs are
Is
very
it
less.
like real-time sync it does, or is it offline?
No, it's real time sync. So when you configure multiple regions, if I say, let's say I have chosen a strong consistency model, then in that case, when both of the region have enough quorum, then only I will say you will get the response that the write has happened. So let's say if you configured a region in South India and you have configured a region in East US, when both of these regions have enough quorum for the write, then only you will get the response back to your client machine that your write has happened.
So that also involves the cost in the other region.
Yeah, so it's yeah, definitely. So how many number of regions you configure, based on that your cost will definitely increase, because you have to maintain multiple regions, you have to do real time writes, replication, and all those things. So cost increases with that, but you have the option available and you don't need to think about it at all. So, and I'll share the RTO and RPO related calculations to you after this.
Now you can say thanks, Erin.
So I think we don't have much time left to do a deep dive, but I'm happy to connect after this, and I would encourage all of you to try out Cosmos DB. Since most of you are students, I would like to you to go and check out Cosmos DB. We have a free tier option available where you get some default. You don't need any credits, Azure credits for that. You just create a subscription and start using Azure Cosmos DB free tier.
We also have student discounts, so that is also there.
So if you want to check out other Azure offerings apart from Cosmos DB, we do have student discounts and default Azure credits. So for Cosmos DB, you don't need any of that. You can just go ahead and try out, create a Cosmos DB container, and do all of the operations that you want. Choose any API you want. You can experiment with different APIs, either Mongo, Cassandra, NoSQL, SQL, any of them. So yeah, and I'm happy to connect afterwards for any questions. Thank you very much. It has been lovely session.
There's going to be a break of 10 minutes right now. I think you needed a lot of break after some security stuff. It's time for us to network.
Yeah.
Richa is from the Cosmos DB team, so you can really ask her, no SQL में industry में क्या चल रहा है. She will be knowing it, of course, for sure. And of course, he's a security guru here. Anything related to security is there. IoT का guru भी है. हम तो पता नहीं किसका गुरु है. तो ठीक है, let's connect, let's energize. The session will start in 10 minutes after, and he will be there. And of course, we have ordered some pizzas from our side, so stay for the pizzas, don't worry. Your day is not wasted. If you feel it's wasted. Oh, send it right now. See, So sorry for that. I was on mute. So hey friends. All right, just mute.
Yeah, now you can start.
So, hey friends, now it's time for you to go ahead and start learning about GitOps. GitOps has been something more phenomenal in terms of getting right DevOps practices and also security out there. So, it's time for you, sir. So, go ahead.
Hello. Hello. So, so today the topic is more on. My topic is more on the DevOps part of it. As I understand, most of us are new to this DevOps, right? We have a number of tools available. Just to give a background, because I just don't want to start from giving the technical things which you won't be able to understand. So, how many of you have heard about the term DevOps at least? Okay, five, six of them. Okay. When it comes to DevOps, when I say cloud and DevOps go hand in hand. So cloud, any deployment, anything which you have to deploy on cloud, right? It has to do some in automation way. So DevOps